My name is Brant Shields. I'm the Advanced Technology Technical Manager for Advanced Services. I'm going to do a presentation on guided wave ultrasonics. The two systems that we operate are the teletest focus, and the second system we're looking at is the guided wave G3 system. There are three basic components to the system. This is the actual guided wave ring that gets applied to the pipe. This is a 6-inch collar. On the inside of this collar is loaded with spring-loaded transducers. It gets wrapped around the pipe. In turn, two LEMO connectors are connected and ran to the G3 unit. This is what actually creates the torsional waves that go down the pipe. Once this is connected, the umbilical cord is connected and run to just a laptop that's running the G3 software, which is the WaveMaker Pro software. Once all this is hooked up, setup time is approximately anywhere from 5 to 7 minutes. Once everything's hooked up, we can put in all the data we need, pipe specifications. We can put in lengths that we want to shoot, any kind of coating damage that we see, any notes that we want. Once everything's set up in the system, then we go ahead and we collect data. And as we're collecting data, the system has a self-redundancy check where we can check coupling for the transducers going onto the pipe, and we can check capacitance to make sure we have no errors or no defaults. Depending on the length of pipe that you're shooting, the system collection time is about anywhere from 7 to 10 minutes. Once the data is collected, we get a screen representation of exactly what the pipe looks like and any cross-sectional features that we want to look at. The green line noted right here is where the collar position is. The gray line represents the near field. We're shooting the pipe in two different directions. If we look at the pipe where the collar positioned at, from this pipe down this length of pipe is shooting in the negative direction, and down this length of pipe is shooting in the positive direction. We can look at our negative direction and we can see a tall peak right here. Very symmetrical trace, and what this is denoting is the butt weld right here, approximately 10 foot, 10 inches away from the collar position. Once this is done, the screens are analyzed and we can denote corrosion, which we're looking at right here. We have a small peak right here that has symmetrical and axisymmetrical response. A lot of red flexural in it. So we know we have something that's in the pipe that's local, very small, very isolated, but fairly deep. And if we look down at the pipe at this location right here, we can see we've got some artificial defects in the pipe. That's denoted that the system picked up. Now, once this is interpolated, everything's labeled and marked, we can let the client know, we can let the customer know exactly where his probable concern is at, what we found, what the extent is, and what should be proved up. Ideal areas that we want to examine using guided wave ultrasonics are things such as road crossings, dike berm crossings and tank farms, buried pipelines, highway crossings, cased road crossings, and any inaccessible pipe that you really can't get to. Collar application is fairly easy. It goes from 2-inch, and here's a 2-inch guided wave collar, from 2-inch to 36 inches. Sometimes we get asked to do larger than 36 inches, and right now we can go up to 56, which is a lot of transducers, but we can do up to 56 inches. Once the collar is placed on the pipe, approximate test time to result time is about 20 to 25 minutes. That's the gist of the guided wave and how it works.